Good afternoon, everybody. Today we have seen already part we have seen in last lecture, that is revised part. That is, we know that we have just started the chapter that is field effect transistor. Right now we have seen that what do you mean by field effect and whatever the effect of it, it is the different than that of your BJT. Did you getting my voice? Please reply.
Yes, sir.
Okay. See, field effect transistor is same as like as your transistor, but there are some of the difference between your field effect transistor and your transistor. Transistor indicates that bipolar junction transistor. Which are the difference that we have to be discussed now? And after all, we have to be seen the field effect transistor. See, we know that BJT is nothing but a bipolar junction transistor. It have current conduction takes place due to the both, that is electron as well as holes, right? That's why it is called as bipolar junction transistor. But in case of your field effect transistor, there should be current conduction takes place due to the only either your holes or electron. That's why FET is a unipolar devices, right? This is the thing with respect to FET. And one of the other thing with respect to your BJT is that why I'm discussing BJT with respect to FET. That is the we first see why we have to be prepare the FET. That's why we have to be seen the what would be the difference between FET and BJT. Then we have to be start other things, right? See, BJT is the device which is called as bipolar junction transistor. If it is called as field effect transistor, see, field effect transistor is a voltage controller device. Means applied voltage means gate to source voltage that should be controlled by your drain current. Means input VGS voltage, output drain current. This will be happen in case of APT. But in case of your transistor, that is bipolar junction transistor, we have applied the base current. We have to be control the collector current, right? So input current, output also current. This is the thing. So controlling of the input is current and output is current. In that case, is not easy, right? But in case of APT, it is easy because applied input voltage which should control the output current, right? And another thing with respect to BJT and APT is that BJT have the low input impedance. So low input impedance indicate that noise is added with it, but APT doesn't noise is added. Why it is? See, reason behind it is APT have the high input impedance. See, this is the thing with respect to the APT. Now we have seen the what done by APT. See, APT indicate that field effect transistor. Normally, it is electronic devices, right? So for that electronic device, we have applied the input voltage, right? Voltage between your gate to source. See, input voltage indicate that we have there are three terminals with respect to APT. One is your gate, drain, source. Two working on it, we have applied the voltage between gate and source, right? So VGS voltage is applied across it, right? So applied VGS voltage indicate that electric field. That voltage is nothing but a due to the application of particular voltage. See, due to the application of particular voltage, there should be generation of the electric field, right? So that's why we have applying the voltage. So that voltage is nothing but an electric field which is used to control the flow of the current. So it is nothing but a we have applied the input in between your gate to source, that is it induce the induce the electric field which applied induce the electric field which control the output current, that is drain current. This will be the thing with respect to your field effect transistor, right? Field effect transistor have three terminal, which are that I'm telling you. If it have the source, gate and drain, these are the three terminal with respect to field effect transistor, right? So in this case, gate, drain, source, that are the three terminal which are used for the purpose of different operation with respect to your field effect transistor. See, APT have the applied a voltage. We have applied the voltage, that is a voltage in between your gate to source which control the drain current. This will be happen with respect to your APT, right? So in this case, we have applying the voltage between gate to source which control the output current. Output current is nothing but a drain current. Okay. See, we have seen these differences. Is it needed to repeat it? Differences repeat करायची गरज आहे का? Please tell me. गरजेचं आहे का differences repeat करायचं?
No, sir.
Okay. See, we have seen actually field effect transistor and what will the family of field effect transistor, that we have to be seen in this, right? Field effect transistor indicate that normally we know that see, 5 we have to be discuss the things related to the transistor with respect to APT. See, APT basically APT is a transistor, not any other thing, but the whatever the effect or whatever the output coming with respect to a field effect transistor, that should be only somewhat changes. That's why we have to be seeing the field effect transistor, we have to be going towards the transistor, right? We know that there should be some of the same thing and some of the different thing with respect to these two transistor. Basically, both bipolar junction transistor and the field effect transistor, both are the transistor, but they have some of the identified differences with respect to it. See, when we have seen the transistor indicate that bipolar junction transistor. So bipolar indicate that, its name indicate that bipolar indicate that there should be current conduction takes place due to the both, that is electron as well as holes, right? That is nothing but a bipolar junction transistor. So in case of your bipolar junction transistor, there should be either your majority or minority. See, if we have to be considered as a NPN type of transistor, in that case there should be majority of the, tell me, in case of NPN type of the transistor, there should be majority of the कशाची majority of the ऐकू आलं नाही मला प्लीज
Electron.
right, because 2n 1p, so it indicates that there should be majority of the electrons. If the PNP, it have the majority of the holes, right? So in case of BJT, there should be current conduction due to the both, that is a majority as well as minority carrier, right? This will be happen with respect to the BJT, but in case of APT, there should be current conduction takes place due to the only majority charge carrier, right? So here is not only current conduction takes place due to the both, that is electron as well as hole. Here, which is measure, either your electron or either your holes, that should be measure, and current should be flow only that. That is nothing but a APT. Okay. So APT, micro APT has capability of amplify small signal up to frequency range of the X band. See what it indicate that. See, when we have to use the transistor for our different application, it have limited range of application. Limited range म्हणजे काय असतं की जर आपल्याला फ्रिक्वेन्सी दिली असेल 10 किलोहर्ट्ज 10 to the 10 किलोहर्ट्ज, एवढ्या स्मॉलेस्ट फ्रिक्वेन्सी रेंज मध्ये तुमचे ट्रान्झिस्टर वर्क करतात, पण ग्रेटर दॅन दॅट ऑफ दॅट फ्रिक्वेन्सी इट इज नॉट युज्ड. But in case of APT, it should be used from start from 10 kilohertz to the megahertz, right? This will be changed with respect to APT and the BJT. Okay. See, types of FET divided into JFET and MOSFET. We have tell you FET indicate that field effect transistor, right? Field effect transistor. It have two types. One is JFET, other is MOSFET. See, JFET indicates that junction field effect transistor, right? Junction field effect transistor. Other MOSFET. MOSFET is called as metal oxide semiconductor field effect transistor, right? JFET indicate that junction field effect transistor. MOSFET indicate that metal oxide semiconductor field effect transistor. See, JFET, the difference between JFET and MOSFET is that in case of MOSFET, in case of JFET, tell you, in case of JFET is silicon or germanium conductor used as their construction, right? In case of JFET, but MOSFET, we have used the germanium as well as silicon, but other thing indicate that metal oxide also used for the construction of your junction field effect transistor. Then it is called as MOSFET. It is also called as IGFET, insulated gate field effect transistor, right? IGFET indicate that insulated gate bipolar insulated gate field effect transistor. Okay. See, MOSFET also have the two types, depletion type and enhancement type MOSFET. So what do you mean by depletion? What do you mean by enhancement? I am tell you. See, depletion indicate that whatever the voltage or current applied across your MOSFET, accordingly means either your current, see, positive applied or negative applied, accordingly it have two types, depletion or enhancement type of the MOSFET. And another thing, due to the application of voltage or current, see, due to the application of voltage and current, there should be positive current or negative current flow. Accordingly, also it have type of the depletion and enhancement type of the MOSFET. Okay, depletion type MOSFET have two types. One is N channel MOSFET and other is P channel MOSFET, right? So N channel, P channel, that are the type for the depletion type MOSFET. Enhancement type of the MOSFET also have two types, N channel and P channel MOSFET. Okay. See, this is the actually symbol of the junction field effect transistor. it is same as like as BJT means NPN and PNP transistor. There are two types of the transistor. With respect to JFET also two types, that is a N channel and P channel JFET. Same thing with respect to NPN type of transistor, there should be majority of the electron. In case of P channel, sorry, in case of N channel JFET, there should be majority of the electrons. Same, N indicate that electrons major, right? Here, less number of here holes also, but that are not affected with respect to FET. का बरं असं लक्षात घ्या, हे कुठलीही डिव्हाइस असेल ना तिथे मेजॉरिटी आणि मायनॉरिटी असे दोन्ही चार्ज कॅरियर असतात. बट मी तुम्हाला काय सांगतो की इथं आपण मायनॉरिटी चार्ज कॅरियर लक्षातच घेत नाही. वाय इट इज, मी ह्याच्या आधी त्यासाठी नोटिफिकेशन एक सांगितलं होतं तुम्हाला, सांगा. See, we have seen that field effect transistor is a majority charge carrier devices. So doesn't need of the minority. म्हणजे minority काय आहे किती आहे काहीच गरजेचं नाही. मेजॉरिटी जे आहे ना त्याच्यामुळे करंट कंडक्शन होतं. So that's why in case of junction field effect transistor, we have seen the N channel effect. So in this case, current conduction phase due to the electron, right? So this will be in case of N channel effect. In case of P channel effect, there should be majority of the P indicate that holes. So here current conduction takes place due to only holes. Okay. Here see this arrow towards the upward, it indicates that N channel JFET. This arrow towards the outside, it indicates that P channel JFET. So in this case, when the N channel current is from your gate towards the source, and when it is a P channel, in that case current from source to the gate. That's why this is arrow. See why the particular terminal are used and why, what are their uses. That's why I have said source indicate that we know that in case of JFET there are three terminal, gate, drain and source, right? So these terminal have specific function. That's why it is design error. So that's according to their function we have to be explained why it is used in a particular case, right? Gate, drain and source, these are the three terminal of the field effect transistor. We have seen the first terminal, that is source. Source indicate that we know that we already know that in case of JFET, this is a majority charge carrier devices, right? So majority charge indicate that if we have to be considered the example of N channel, so N channel indicate that it have majority of the electron, right? So it have majority of electron indicate that in case of source, what it does, the terminal where the majority charge carrier enter the channel, right? So in this case, if we have to be considered as the N channel JFET, in that case your high number of electron that should be entered in a channel, that is called as source terminal, right? So source terminal indicate that this is used for the purpose of entrance of your majority charge carrier to the channel. Channel indicate that portion where large number of electrons flow, that is the portion is called as channel. Okay. Now see drain indicate that the terminal through is the majority charge carrier leaves the channel. Leaves indicate that, see, we know that gate, drain and source, these are the terminal. Source indicate that it should be, means whatever the electrons and source that should be entering in your field effect transistor. But if they entering into, they also going outside, right? So drain terminal is the terminal which we have whatever the electrons or the whatever the holes. I'm telling you either electron or holes, because in case of N channel there should be entrance of the electron. In case of P channel there should be entrance of the holes, right? So that's why whatever the electrons and holes enter from the source, that should be going outside through the drain terminal, right? So gate terminal, what it indicate that, so actually gate, drain, source, these are three terminals. So actually gate terminal is called as control terminal. Control terminal indicate that how the current flow, where it is flow, on what will be the its value, that should be decided by the gate terminal, right? So that's why gate is called as control terminal for the drain current flow, right? So in case of this, there should be current flow due to the both, that is either your electrons or holes. See, when we have to be seen the N channel FET, in that case current conduction takes place due to the electron. In case of p channel, there should be current conduction takes place due to the holes. This is the thing with respect to the field effect transistor. So see, gate is used to control the drain current. The field effect transistor control flow of electron from the source to the drain by affecting the size and shape of the conducting channel. What indicate that? See, I already told you there should be gate is controlling terminal, right? See, in this case, we doesn't apply any current with respect to your field effect transistor. Why it is? Because we know that field effect transistor is a voltage control devices, right? So we have applied the voltage in between gate to source, right? So applied gate to source voltage which control the drain current. This will be happen in case of your field effect transistor. So due to the application of gate to source voltage, accordingly the size of the channel indicate that the area where large number of free electrons and holes enter, right? So this is nothing but a channel. So particular channel size means flow of the electron or flow of electron have area. This is called a channel. So the size means the size of that particular channel should be decided by this gate terminal. All right. So whatever the voltage applied across gate to source, that should be decided the particular flow of the electron and hole. म्हणजे काय असतं सांगतो, गेट टू सोर्सला जेवढं व्होल्टेज आपण अप्लाय करतो ना, त्याच्या प्रमाणात तुमचा कंडक्टिव्ह एरिया म्हणजेच इलेक्ट्रॉन किंवा होल्स फ्लो करायचा एरिया डिसाइड केला जातो. त्यानुसार जर एरिया कमी आहे की जास्त आहे हे डिसाइड करायचं काम तुमचा गेट टू सोर्स अप्लाय केलेलं व्होल्टेज म्हणजेच गेट टर्मिनल करतो. लक्षात घ्या. त्याच्यानुसार तुमचा त्याच्यातनं इलेक्ट्रॉन कसे फ्लो करायचे किंवा होल्स कसे फ्लो करायचे ते डिसाइड केलं जातं. ओके, हा पॉइंट लक्षात आलाय का? म्हणजे 3 टर्मिनल आणि त्याचे युजेस. प्लीज रिप्लाय द्या. लक्षात आलाय? त्याच्याबद्दल कुणाला काय प्रॉब्लेम आहे का? प्लीज रिप्लाय द्या. लक्षात आलाय का?
Yes, sir.
Okay. Normally we have discussing something related to the JFET. Normally junction field effect transistor is the simplest type of field effect transistor, right? Field effect indicate that we have applied the input voltage. Due to that input voltage, there should be creation of the electric field, right? This is nothing but a due to the application of electrical supply or electrical voltage, there should be generation of the electric field. This is nothing but a field effect transistor, right? So in case of field effect transistor, we have applying the gate to source voltage, which causes there should be generation of the electric field. This is related to the JFET. But in case of BJT, what we have to do? See, we have applying the base current, which causes there should be change in a collector current. This is with respect to your BJT. Okay, in JFET, the current flow is due to the majority of the charge carrier. We know that I'm so many times still related to the BJT and JFET difference. That is, BJT is a current control devices, and another thing, BJT is a majority as well as minority charge carrier. It indicates that there should be current conduction takes place due to the BJT, that will be due to the both thing indicate that due to the either electron or due to either your holes. It is not thing. There should be current conduction takes place due to the both, that is electron as well as holes with respect to your BJT. But this is not happen with respect to JFET. Why it is? See, when we have to be discussing the JFET, it indicate that it is a majority charge carrier devices, right? Majority charge carrier indicate that there should be majority of the either your electrons or holes, and the current conduction is take place only due to the either your electrons and holes, right? So that's why in case of your JFET, there should be current conduction takes place due to the only majority charge carrier. This is the thing with respect to the JFET, right? See, where in a BJT, the current flow is due to the both majority and minority. We know we have discussed the same thing now. See, since only the majority of the charge carrier are responsible for the current flow, we know that majority, why the minority charge carrier responsible for the purpose of JFET. पुन्हा लक्षात आलं असेल ना तर ते सांगू शकतात. Why the minority charge carrier are not responsible to flow of the current through the JFET? सांगा, JFET मध्ये minority charge carrier का responsible नाहीत करंट फ्लो होण्यासाठी? पुन्हा सांगता येईल? त्याची कारण इथंच आहेत. आता जे स्लाइड मध्ये जाईल सांगा बरं. प्राजक्ता वेद पाठक सांगू शकता तुम्ही?
Yes, sir.
सांगा करा.
It is a voltage control device.
ते तर कारण आहेच, पण नेमकं तिथं म्हणजे लक्षात घ्या दोन नाही तिथं, मेजॉरिटी ॲज वेल एज मायनॉरिटी चार्ज कॅरियर. पण आपण पाहिलं की जेफेट मध्ये काय करतोय आपण, फक्त आणि फक्त मेजॉरिटी चार्ज कॅरियरमुळे करंट कंडक्शन होतंय, बरोबर. मायनॉरिटी चार्ज कॅरियरचा काहीच इफेक्ट नाही, म्हणजे काहीच रोल नाही लक्षात घ्या. त्यामुळं आपण ते कन्सिडरच करत नाही, म्हणजे मायनॉरिटी चार्ज कॅरियरचा काहीच यूज नाही, तर त्याच्यामुळं करंट कंडक्शन काय होतं किती होतं काहीच रिस्पॉन्सिबल नाही, कारण त्यांना होतच नाही ऍक्च्युली. कारण फेट हे तुमची मेजॉरिटी चार्ज कॅरियर डिव्हाइस आहे, म्हणजे जे मेजॉरिटी आहेत ना त्याच्यामुळेच करंट कंडक्शन होतं, आयदर युअर होल्स असू द्या किंवा इलेक्ट्रॉन्स असू द्या. लक्षात आलंय? लक्षात आलंय ना वेद पाठक?
हो sir.
ओके. See, I have given you the one of the example, right? During that example, you have to be idea about the JFET, right? See, what is this? Just tell me. Water tap. पाण्याचा नळ आहे, बाकी काय नाही, राईट. त्याच्यावरनं दॅट इज द आयडिया अबाउट युअर थ्री टर्मिनल विथ रिस्पेक्ट टू युअर JFET, right? Source, gate, drain. Source indicate, see, you don't see here, don't see the description related to it. According to this thing, you have no whatever thing I can explain you. आता जे मी तुम्हाला एक्सप्लेन केलं होतं ना, ते सगळं त्याच्यावर तुम्हाला लक्ष देईल. See, JFET have three terminal, that is a gate, drain, source, right? Gate, drain, and source. These are the three terminal. Water tap means this connection of water tap. This indicate that actually working of your junction field effect transistor. See, source indicate that it is the bulk source of your water, considered as water, right? So in this case, source indicate that now I'm telling you with respect to water, because this is the water tap. Then I have explained whatever the thing with respect to the JFET, right? See, source indicate that in this case, this should be connected to the whatever the reservoir of the particular water. This should be this tap should be connected to the reservoir of the water, right? So this should be attached with reservoir of the water. So this flow of water is depend on gate, right? Why it is? Because gate indicate that it is a either your on or off switch. It is either your on or off. If it is on, there should be flow of the water. If it is off, it is nothing but a no water which should be going below, right? So this is nothing but a this tap indicate that gate means it should be control the whatever the water coming from below, right? This is nothing but a control. Okay. So drain means whatever the water coming, that should be collected by this part. This is nothing but a drain, right? Now see these three things again. Now see, source indicate that with respect to electronic, तुम्हाला याच्या रिस्पेक्ट टू म्हणजे वॉटर टॅपच्या रिस्पेक्ट टू ह्या थिंग सोर्स, गेट आणि ड्रेन लक्षात आलेत का सांगा. परत एकदा सांगू, सोर्स इंडिकेट काय असतं लक्षात घ्या की एक रिझर्वायर, म्हणजे समजा एखादा तुमचा पाण्याचा टँक आहे, लक्षात घ्या त्या टँकला आपण हे वॉटर टॅप बसवलेले, म्हणजे सोर्स हा तुमच्या सोर्स जो टर्मिनल आहे ना तो तुमच्या एका रिझर्वायरला म्हणजे पाण्याच्या मोठ्या साठ्याला एक कनेक्ट केलेला आहे, लक्षात घ्या कनेक्ट केलेला आहे. त्याच्यानंतर इथून पाणी इथपर्यंत आलं, पण ते पाणी खाली जायचं कंट्रोल हा तुमचा गेट करतो, लक्षात घ्या. म्हणजे हे गेट काय करणार आहे, त्याला पुढे पास करायचं का नाही ठरवणार आहे, बरोबर. आणि हा ड्रेन काय करतो, ते इथून सोर्सनं पाठवलेलं गेटनं कंट्रोल केलेलं पाणी ड्रेन हा कलेक्ट करायचा काम करतो. आता एक याच्या रिस्पेक्ट वॉटरच्या रिस्पेक्ट टू थ्री थिंग लक्षात आले का, सोर्स, गेट आणि ड्रेन काय असतं, प्लीज रिप्लाय द्या.
Yes sir.
Okay, now we have to be discuss the same thing with respect to electronic, that is JFET. See, source indicate that it is the source indicate that it is the majority charge, it is the source of the majority charge carrier. See, source indicate that it is connected to the source of the majority charge carrier, right? Source of majority charge carrier indicate that either your n channel or p channel. See, in case of n channel, there should be majority of the electron. Either it is a p channel, it should be majority of the holes, right? So source indicate that we have connected this tap to the majority charge carrier of the particular JFET, right? This should be majority charge carrier traveling from this source terminal towards the gate terminal, right? So gate indicate that it is the terminal which should be control the flow of the particular whatever the majority charge carrier which should be entering from your source towards the drain, right? So the gate indicate that it is the control terminal for the purpose of your whatever the electrons or holes coming from your source. So gate indicate that it is the control terminal which should be see the flow of the whatever the electrons and holes coming from your source terminal. Okay, this will be the thing with respect to gate. Then whatever the majority charge carrier coming from your source, that should be traveling from your source towards the drain. So during that portion, gate is control terminal, so that's why whatever the electrons and holes coming from source, that should be collected, means that should be given to the drain, right? So drain is nothing but a collector terminal of whatever the majority charge coming from your source to the drain. Okay, कन्सेप्ट लक्षात आलाय का? सोर्स, गेट, ड्रेन, वॉटर टॅपच्या रिस्पेक्टिव्ह. नसेल तर आणखीन एकदा मी रिपीट करतो, सांगा मला. आणखीन एकदा सांगतो मी, लक्षात घ्या. सी this water tap concept which will be related to the junction field effect transistor, right? Source indicate that this is tap, this is a water tap, this water tap connected to the majority charge carrier. It is nothing but a reservoir or water reservoir. In this case, it is connected to the water reservoir. So now it should be considered as a water reservoir, it should be considered as a majority charge carrier, right? So it should be considered as a majority charge carrier. So large number of majority charge carrier, source is nothing but a source terminal, right? See, so large number of majority charge carrier traveling from your source to the drain. So before traveling from your source to the drain, it should be controlled by this gate terminal. So it indicates that it is the one of the tap which should be, this gate should be one of the tap which should be control the flow of the whatever the majority charge carrier traveling from your source to the drain. So gate indicate that it is the control terminal to give the flow of the source to the drain electron or holes, that is majority charge carrier. Okay, so whatever the majority charge carrier coming from your source traveling through the gate, that should be collected by this terminal. This is nothing but a drain terminal. This is the thing with respect to the JFET. आता लक्षात आली का सगळ्यांच्या?
Yes, sir.
Okay. See, this is the actually diagram, constructional diagram of the n-channel junction field effect transistor. See, what do you mean by n-channel? What is the concept of channel that we have to be seen here? See, basically, this is the construction of the your junction field effect transistor. It have basically three terminals, that is a gate, drain, and the gate, drain, and the source. These are the three terminals with respect to your junction field effect transistor, right? So see, it is nothing any other. You have to know about the PN junction diode. PN junction diode माहित आहे? Please tell me, PN junction diode. याच्यासाठी दुसरा तिसरा कन्सेप्ट काय सुद्धा लागणार नाही, पीएन जंक्शन डायोडचा कन्सेप्ट फक्त इथे लागणार आहे. सी, before that I am explaining what is the name of the particular termination. See, it have three terminal, gate, drain, and source. This middle portion is portion between two p layer, right? This two p layer indicate that gate terminal. So internally this p is connected to the other p, right? Internally they have connected to each other, and this after connection that should be taking over, that should be called as gate terminal. Okay, gate terminal. After all that, the portion between two p layer, middle portion, that layer is called as channel. In that case, n channel indicate that there should be majority of the electron, right? N is part of it, so that's why called as n channel. Okay, see, when we have to be discuss the thing with respect to, this is a p terminal, this is the n terminal, right? So we know that if the any of PN, here PN, right? PN is nothing but a, you tell me, what do you mean by PN? Where it is used in case of your diode? PN जंक्शन डायोड ऐकले ना, पहिल्या चॅप्टर मध्ये आपण पाहिलेलं आहे PN जंक्शन डायोड, राईट? सो नो एनी अदर थिंग, म्हणजे दुसरा कुठलाही कन्सेप्ट इथे लागणार नाही, PN जंक्शन डायोडचा कन्सेप्ट फक्त आपल्याला लागेल. सी हिअर when we have to be discussing with respect to the n channel JFET, in that case we have seen that here is a P, here is a P, 2P which should be connected to way of your junction, right? Two-way connected this 2P, and middle portion in between 2P, there should be one N is connected across it, but this is called as portion. This portion is called as N channel. This should be act as a channel because here we have to be flow of the current should be happen. Okay, see, this is called as N. So see, it have three terminal. We know that accordingly these three terminal, either your gate, drain, and the source, these are connected to the outer part. See, these are connected to the outer part due to by using this one of the contact, it has some of the small resistors. म्हणजे एक कॉन्टॅक्ट असा यूज करायचा, म्हणजे कॉन्टॅक्ट आयदर मेटल असेल, समजा एक मेटल असं यूज करायचं की ज्याला कमी रेजिस्टन्स असेल किंवा रेजिस्टन्स थोडासा असेल, त्याला म्हणतात ओहमिक कॉन्टॅक्टद्वारे ते बाहेरच्या वर्ल्डशी कनेक्ट केलेले असतात. ओके, ओहमिक कॉन्टॅक्ट. सी, we have seen that this P, N and P, right? So it is nothing any other, it should be act as like as your PN junction diode only. Why it is PN junction diode सारखंच आहे, कशामुळे बरं? टेल मी, see the diagram and tell me why it is not any other thing, it is same as like as PN junction diode. Why it is? Tell me. कोणाला काय याच्यावर रिस्पेक्ट टू कळत असेल तर हे दुसरं तिसरं काय नसून PN जंक्शन डायोड आहे, लक्षात घ्या. का असं म्हणतोय मी? प्लीज टेल मी व्हाय इट इज. The reason behind it is this is a P, this is N, this is a P, this is N. So this 2P is connected each other, so it is nothing but only P, right? This P and N that should be coming across here. We know that PN indicate that PN junction diode. Okay, this is, you know, PN is nothing but a PN junction diode. So all of the property of PN junction diode that should be coming with respect to this type of the configuration. हे लक्षात येत आहे का? हे दुसरं तिसरं काय नसून आपण पाहिलं की याच्यातलं पार्ट अशा प्रकारे कनेक्ट केले की पीएन जंक्शन सारखं फॉर्म झालेलं आहे, बरोबर? पीएन जंक्शन सारखं फॉर्म झाले म्हणल्यानंतर सगळ्या पीएन जंक्शनच्या प्रॉपर्टी असतील ना त्या इथं आपल्याला लागू होतील. लक्षात येत आहे का? प्लीज गिव्ह मी रिस्पॉन्स.
Yes, sir.
Okay, so we know that PN junction diode that should be constructed by either your silicon or germanium, right? So silicon is the device, it have one of the voltage that is called as cut-in voltage, right? Means when we are applying the voltage to the diode, in that case up to the 0.7 volt. In case of silicon it is not worked, right? In case of your germanium it should not be worked up to the 0.3 volt, right? So up to that voltage it should be called as cut-in voltage, right? Turn on voltage of the particular transistor. So that's why same thing will be happen in case of this PN junction diode, right? Why it is happen? See, PN junction diode, see PN junction diode in P have majority कशाची असते सांगा बरं?
Holes.
Right, P have majority of the holes, here have majority of the electrons, right? So it is nothing but a holes and the electrons, right? These are nothing but a opposite charge carrier. Do you understand? P and N that are nothing but a opposite charge carrier. P indicate that holes, N indicate that electrons. So what happened with respect to this? कोणाला काय सांगता येईल? लक्षात येते कन्सेप्ट? पी मध्ये मेजॉरिटी होल्स आहेत, एन मध्ये इलेक्ट्रॉन्स आहेत, राईट? पी मध्ये होल्स आणि एन मध्ये इलेक्ट्रॉन्स आहेत, दे आर कनेक्टेड टू नियर बाय. तर काय होईल विथ रिस्पेक्ट टू डायोड सांगा? See, we know that I just tell you the concept of the opposite poles are always attracted. That is the thing with respect to here. No any other things happen. All of the thing which should be happen with respect to that all things happen with respect to Pn, right? See, in this case P and N, in this case, P have the majority of the holes, N have the majority of the electrons. We know that when P and N are connected to each other or nearby to each other, there should be P have the majority of the holes, N have the majority of the electron. So due to that, they are nearby. That's why what happened, due to that, electrons from N and the holes from P are coming to the middle portion, and they have to mix each other, right? Opposite charge एकमेकांशी अट्रॅक्ट करत असतात, त्यामुळे काय होईल, पी मधले होल्स म्हणजे प्लस आणि एन मध्ये इलेक्ट्रॉन प्लस मायनस एकत्रित येतील आणि ते रिझॉल्व्ह होतील. लक्षात घ्या, पी आणि एन जंक्शन, पी आणि एन म्हणजे याच्यातले इलेक्ट्रॉन्स याच्यातले होल्स आणि याच्यातले एन एकमेकाशी रिकंबाईन होतील आणि रिकंबायनेशन झाल्यानंतर ते डिफ्यूज होतील, राईट? ही प्रोसेस स्मॉल टाइम, ड्युरिंग स्मॉल टाइम दिस विल बी हॅपन. एक लिमिट पर्यंत म्हणजे काही वेळापर्यंत म्हणजे इन मायक्रो सेकंड, म्हणजे पी मधले होल्स आणि एन मधले इलेक्ट्रॉन्स दे आर मिक्स इच अदर and they have diffused each other. This will be happen, right? Up to small time this will be happen. After all, what happen, whatever the electrons and holes coming diffused here, there should be short layer is formed. That layer is called as depletion layer. See, that layer is called as depletion layer. Why that happen? See, it have its capacity, म्हणजे पी मध्ये मेजॉरिटी समजा होल्स आहेत, एन मध्ये इलेक्ट्रॉन्स आहेत, ते एकमेकाशी रिकंबाईन झाले, हे स्मॉलेस्ट इव्हेंट होईल. तर त्याची ओन कॅपॅसिटी आहे, किती वेळ व्हायचं ते एकमेकाशी रिकंबाईन झाल्यानंतर देर शुड बी फॉर्मेशन ऑफ, when it is recombined, there should be a formation of one of the layer between your p type and n type, right? This layer is called as depletion layer. So due to that depletion layer, there should not be further over electrons from n, holes from p are not mix each other, right? So this is called as depletion layer, or यालाच अडथळा असं म्हटलं जातं, लक्षात घ्या, right? Depletion layer. So due to that depletion layer, that's why there should not be electron from n and the holes from p, they are not mix each other. This will be happen in case of p-n junction diode, right? I'm telling you, I'm again tell you p-n junction diode, because this is a basically p-n junction diode. Either it is a field effect transistor, but now it is a p-n junction diode. Why it is? Because it should be basically act as a p-n junction diode. So all of the functional thing that should be coming with respect to p-n junction, that also applied for this configuration. See, that's why here in between p and n there should be formation of the depletion layer. Same thing will be happen across here, because it is also p-n junction diode. See, p-n, it also the p-n junction diode. So same thing which will be happen here, that also happen across here. This will be happen to the with respect to this p-n layer also. This is the thing with respect to the construction of the n-channel junction field effect transistor, right? So how the flow should be increase or decrease, that we have to be see. याच्यातला फ्लो कसा कमी किंवा जास्त केला जातो ते सांगतो. सी, बाय increasing the size of this depletion layer, काय इफेक्ट होईल का रे? म्हणजे काय सांगतो, समजा हा डिप्लेशन लेअर इथं आहे, तो समजा इथं आला, याचा डिप्लेशन लेअर आहे तो समजा इकडे आणला, तर याच्यातला करंट फ्लो होण्यासाठी, म्हणजे तुमच्या सोर्स कडनं ड्रेन कडे करंट फ्लो होण्यासाठी काय फरक पडेल का, मला सांगा. आय एम अगेन टेल यू व्हॉट वी हॅव टू डू. वी हॅव control indicate that we must apply the voltage through the gate and source. Why it is? Because we know that gate is control terminal, right? So control terminal we have applied the voltage, that is the thing which should be changed with respect to the junction field effect transistor, right? So in this case we have applying the voltage between gate to source. So we have applying the voltage between gate to source such a way that which causes this depletion layer going towards the here, consider as here, and this depletion layer also coming across here. So middle portion from here to here, that should be reduce or increase, that is tell me. मला काय म्हणायचं सांगतो. मी काय केलं, गेट टू सोर्स व्होल्टेज असं अप्लाय केलं की जेणेकरून डिप्लेशन लेअर आहे ना, त्याची साईज वाढली, जे तो इथपर्यंत आला, असा पूर्ण लेअर आहे इथपर्यंत आला हा, आणि परत हा लेअर सुद्धा जो इकडून असा वाढला, तो पण इथं आला. तर तुमच्या करंट फ्लो साठी जो लेअर लागतो तो कमी होईल, म्हणजे करंट फ्लो साठी जो पोर्शन होता तो वाढेल का कमी होईल?
कमी.
एकदम बरोबर आहे. दॅट इज द थिंग. why it is happen? See, due to the application of this voltage, I am not telling you this is the positive or negative. Accordingly, there are different type of the junction field effect transistor, right? So due to the application of this voltage, if we have to be considered as this depletion layer size, it should be increases. Depletion layer size increases, it indicate that whatever the portion, see, whatever the middle portion that should be required for the current flow, that should be reduces, right? That should be reduces. So due to that, there should be current conduction increase or decrease, right? This will be the way for the control of your junction field effect transistor. लक्षात घ्या, हा जंक्शन फील्ड इफेक्ट ट्रान्झिस्टरचा कंट्रोल आहे. म्हणजे ऍक्च्युअली जंक्शन फील्ड इफेक्ट ट्रान्झिस्टर मध्ये काय करतो आपण, व्होल्टेज अशा प्रकारे अप्लाय करतोय की पहा, ड्यू टू द अप्लिकेशन ऑफ दॅट टाइप ऑफ द व्होल्टेज वी हॅव टू बी एनहान्सेस or increases or decreases the layer, middle layer of the gate, and accordingly there should be flow of the current increase or decreases. How it is that we have explained in a further session, right? पण इथे एवढं लक्षात घ्या की तो इन्क्रीज किंवा डिक्रीज हा तुमच्या अप्लाय केलेल्या व्होल्टेज मध्ये होतो. जर हा जर करंट फ्लो होतोय, हा डिक्रीज केलाय, तुम्ही डिक्रीज केलाय म्हणजे काय केलंय, डिप्लेशन लेअर वाढवला. आता जर मला इन्क्रीज करायचं असेल तर काय करावं लागेल बरं, डिप्लेशन लेअरची साईज वाढवावी लागेल का कमी करावी लागेल? सिंपल क्वेश्चन आहे,
कमी करायला.
right? Because when the size of the depletion layer increases, it indicates that this part, depletion part, one time is coming, then depletion part, these two depletion part are connecting to each other, so area for this conduction is reduces, right? So to increase the area for this, it indicates that we have required more and more path between this, right? This is the thing with respect to the JPET. Okay, see, normally N channel JFET consists of 2p type heavily doped region. See, whatever I am telling you, this is the N channel. N channel, what it indicate that this middle portion which is required for the current conduction, right? This is the middle. N channel indicate that this is the portion. This is the portion where used for the purpose of current conduction. 2p layer which should be attached between two different part of this JPET, right? म्हणजे त्याच्या दोन्ही साइडला 2p लेयर कनेक्ट केलेले आहेत, राइट? मीन्स इन बिटवीन 2p लेयर देयर शुड बी फॉर्मेशन ऑफ मिडल लेयर, that is nothing but n layer. So in case of JPET there should be formation of the n channel only due to the 2p layer which should be attached to part of the gate, right? This is the thing with respect to the gate. Okay, whatever I can explain that should be in this slide. See, 1 minute, see this slide. This thing related to the particular concept means gate, drain, source. What do you mean by gate? What do you mean by drain? What are their uses? What are the things which should be related to the gate, drain, and source? What is their application that we have to be seen here? Okay. See, one thing remaining with respect to P and N, right? There are two layer. See, there are two particular layer of the P and N, right? P and N. So in this case, doping is important concept. Doping means what I'm telling you. Doping indicates that adding impurity in a pure semiconductor, right? So in this case, 2p layer indicate that these two layer which should be connected to each other. So in this case, 2p layer have the high doping. High doping indicate that it have large number of impurity added with respect to this configuration, and in case of N type there should not be large number of impurity added. 5 impurity added in a semiconductor. लक्षात येतंय का? कोणाला माहित आहे का सांगा, असेल तर मी सांगतो तुम्हाला. त्यालाच डोपिंग असं म्हणतात. डोपिंग इंडिकेट दॅट ऍडिंग इम्प्युरिटी इन अ प्युअर सेमीकंडक्टर. तर ती इम्प्युरिटी काय ऍड करायची, त्याचा इफेक्ट काय होतो, कुणाला माहिती आहे का सांगा, का मी सांगू? प्लीज रिप्लाय द्या. माहिती आहे का मी सांगू? अनिशा नागटे मी सांगू? कार्तिका नागणे? माहित आहे की सांगतो मी तुम्हाला. ओके, लक्ष द्या एकदा.
सांगा.
ओके, सी वी हॅव सीन द थिंग विथ रिस्पेक्ट टू द. आता मी तुम्हाला काय काय विचारलं होतं? 2 थिंग होते, त्यातली कुठली थिंग तुम्हाला विचारली होती?
डोपिंग का करतात?
हॅलो, आवाज आहे ना? हॅलो, आवाज येतोय?
डोपिंग का करतात?
एक मिनिट. हा बोला. हॅलो,
पी आणि एन जंक्शन मध्ये डोपिंग का करतात?
मिनिट, आवाजच येईना तिकडून.
हॅलो सर.
हॅलो, आवाज येतोय? माझा आवाज येतोय का?
हो सर येतो.
आता सांगा काय सांगितलं होतं मी तुम्हाला? 2 क्वेश्चन विचारले होते, त्यातले दोन्ही पण सांगा. पहिला कोणता विचारला होता?
पी आणि एन जंक्शन मध्ये डोपिंग का करतात?
हा, डोपिंग. आणि मला वाटतं एकच विचारला होता डोपिंगच्या रिस्पेक्ट टू. आणि डोपिंग म्हणजे काय असतं, राईट? सेकंड क्वेश्चन होता. डोपिंग इज नथिंग बट ऍडिंग इम्प्युरिटी इन अ प्युअर सेमीकंडक्टर, राईट? सो व्हाय वी नीड ऑफ द ऍडिंग इम्प्युरिटी इन अ प्युअर सेमीकंडक्टर? सी when we have to use the pure semiconductor. लक्षात घ्या, सिलिकॉन किंवा जर्मेनियम आपण आपल्या ऍप्लिकेशन साठी आपण यूज केले, राईट? सी इन केस ऑफ नॉर्मल टेम्परेचर दे आर नॉट युज्ड और दे आर ऍक्ट ऍज अ insulator, right? In a normal temperature means, in a normal temperature means room temperature they act as a insulator, right? So why it is used? See, when we know that conductor, semiconductor and the insulator, that are the 3 type of the material, right? When we have to be use the semiconductor in case of your normal room temperature, they have act as a insulator. How it is, why it is used? So that's why we to increase the conductivity of the semiconductor, we have adding the impurity on that semiconductor, right? So adding impurity in a pure semiconductor, it is called as doping, right? Adding impurity in pure semiconductor, it is called as doping. So in this case, for this 2p layer, we have added more impurity, right? More impurity indicate that more electrons and holes or more current flowing through this type of the configuration. That is the reason behind it, no any other reason, right? डोपिंगचा कन्सेप्ट आपल्याला माहिती करायचा होता. डोपिंग म्हणजे इम्प्युरिटी याच्यावर ऍड करायची. इम्प्युरिटी काय ऍड करायची? जास्तीत जास्त पी ह्या 2p लेअर मध्ये ऍड केले जाते. याचं रिझन आहे की त्याच्यामध्ये कंडक्टिव्हिटी जास्त असायला पाहिजे कम्पेअर टू दिस एन लेअर, राईट? त्यामुळं आपण ह्या 2p लेअर ह्या अशा प्रकारे डोपिंग करतोय. मीन्स ऍडिंग डोपिंग विथ रिस्पेक्ट टू दिस 2p लेअर सच ए वे दॅट विच कॉजेस more and more electrons and holes flow through the device. Okay, डोपिंगचा कन्सेप्ट लक्षात आला? डोपिंग म्हणजे ओके, टाइम इज ओव्हर. गिव्ह मी अटेंडन्स. रोल नंबर 1
प्रेझेंट.
1 2
प्रेझेंट.
3
प्रेझेंट सर.
4 5 6
येस सर.
7 8 9.
प्रेझेंट. 8 प्रेझेंट सर.
Okay, 9 10
प्रेझेंट
11
सर.
11 12
प्रेझेंट सर.
13 14
प्रेझेंट सर.
15 16 17
प्रेझेंट सर.
17 प्रेझेंट का? ओके 18
16 प्रेझेंट.
ओके 18
Yes, sir.
19 20
Present, sir.
21
Yes, sir.
22
Yes, sir.
23 24,
Yes, sir.
25, 26,
Yes, sir.
27, 28, 29,
Yes, sir.
30,
Yes, sir.
31, 32,
Present, sir.
33,
Yes, sir.
34,
Yes, sir.
35,
Present, sir.
36, 37, 38, absent number 5, 7, 9, 11, 13, 15, 17, 19, 20, 21, 23, 25, 27, 28, 31, 36, 37, 38. Okay. Okay. टेस्ट सॉरी आज पेपर असेल आपला EDC चा. काल मीटिंग मध्ये होतो त्यामुळे माझ्याकडनं राहिलं होतं खरं तर टेस्ट टाकायचं. परत सरांनी टाकली वाटतं.